Good afternoon, friends. So far, we are seeing the partial differentiation. In that, we are starting from your introduction of your differentiation. Then we have seen definition of partial differentiation, total differentiation, successive differentiation, and last lecture we have seen the important topic that is nothing but your exact differential. Okay, and in that we'll get f is the function and its derivatives is continuous, so that we have seen, and the given function is constant. So today we'll see about your chain rule. So this you already used in several ways. Okay, so this probably not new for you, maybe you don't know the name, but many times you are used. For example, this is y is equal to ln of sine of twice x. Okay, and your aim is to find out dy by dx. So we know derivative of ln of x is nothing but 1 by x. So this is 1 upon sine of twice x into derivative of d by dx of your sine of twice of x. Okay, then we can write this is sine of twice of x. This is d by dx, sine derivative is cos. So this is cos of twice of x into derivative of this 2x. So this is your twice of x. Okay, so that is nothing but 1 divided by sine of your twice x into cos of 2x into 2 is constant which is outside, and dx by dt dx is your 1. So that is nothing but 2. So we can write this is 2 times cot of twice x. Okay, so this one way you can see, or another way you can substitute the value, just like u is equal to your sine of v is your twice x. So how we can write this is dy by dx. So this is nothing but dy by dx. I can write in different way. This is y is a function of now v. Okay, so this is dy by du. Okay, now u is a function of v, so this is d times v into v is a function of x, so v times your x. If you cancel, you will get original dy by dx. So this is one way you can find out this one. So it is just like a composite function. Okay, so here is sine and another function. So it is just like, suppose you have taken any function. Okay, so g of n inside that particular thing. So one function which is depend upon another function. So for that case we can use chain rule. Another example we can take here. Okay, so this is one way you can substitute and you will get values. Second is your y is equal to 2t square and sine of t. Okay, so this function I will take over here, or this I can consider 0. This is one and the same thing. Okay, now this is nothing but, my aim is what, dz by dt. So this is nothing but what, I will keep this is constant 2t. So this is nothing but 4t. Okay, 2 is already there, and or otherwise I'll write one more step. So this is 2t sine t is your constant, plus this is 2t square is constant, sine derivative is cos of t. Okay, so I'll get the answer is what, 4t sine t plus 2t square cos of t. Okay, so using substitution, what we can write, this is, suppose x is equal to, I will write this is 2t square, and y is equal to, I will write this is sine of t, and the z is equal to your x into y. And now my aim is what, dz by dt suppose I am to find out. So what I'll do, I will take this is x into your y. So what I will take, this is your dx. Okay, so y times dx by dt, y I have kept constant, plus x constant dy by dt. Okay, now this y I can write in terms of what? Here z is a function of two variable x and y. Okay, so the y I can write in terms of what? Suppose deva z by deva x is equal to, means your z is equal to your xy. So deva z by deva x you can write as a y. So instead of y value I can put this value over here. Same thing for x. So y I can write a deva z by deva x into dx by dt. Okay, plus x I can write in terms of this one, deva z by deva y. Okay, so deva z by deva y is equal to your dy by dt, and this is your dz by dt. So this you have already used in several ways. So this is in general formula in case of your chain rule. Okay, and this is valid, means your z of xy, which is a partial continuous derivative, means continuous partial derivatives of your z and your differential function of your t. Okay, so this is your differential function of t, and this is your d z by deva x and deva z by deva y, which is nothing but your continuous partial differentiation of that particular function. So we'll see this particular formula and their proof. Okay, so that is the case we want to see in your chain rule. So f is a function of two independent variable. I'll write over here x and y, and again the x is a function of u and y is a function of u. Means the given f is a function of two independent variable x and y, and this x is again function of some another variable, that is your u. Now my aim is what? We have to find out what is the change df by du. That I want to find out. What is the change? Means the given function it changes with x and y, x it changes with u. So how df is changed directly with du? That is nothing but your shape. Okay, so in that case the u it changes. U means u changes from u to delta u. Once your u variable it changes from delta u only. Okay, means x is also changes from your x to delta x, y is also changed to y to delta y. If both are changed, then your function is also changed. So f will be changes from f to delta f. Okay, so this we can write over here. So this is f plus your delta f. I can write is nothing but what? This is x, it changes to x plus delta x. So x plus your delta x comma y plus delta y. Now I will take f over here. Same process last time you have seen. So this is f of x plus delta x, y plus your delta y, minus f we can write in terms of f is a function of x and y. So here suppose we have to kept y is constant, so we'll add and subtract one term. Last time you have seen this is f of x plus delta x comma y plus your delta y minus f of, I want to change x, so x, y plus delta y, so y is automatically cancelled, plus I will add one term, same term, okay, it is cancelled and you will get original term, so f of x. Okay, so here is your delta f. So I will divide with, so here please remember x is changes here, y is constant, here x is constant, y is change. So my aim is what? F, how f is changes with u. Okay, so I will divide with delta u function. So delta f means delta f divided by your delta u. Okay, so this is nothing but f of x plus your delta x, y plus your delta y, minus f of x, y plus your delta y, okay, divided by delta u plus f of x, y plus your delta y, minus f of x, y divided by delta u. So this denominator is same and it is cancelled, you will get original term. Okay, so only we have divided with delta u. Now we will take the limit as delta u tends to 0. Yes. Now here the given function is the definition of form. This is x plus delta x, y plus delta y, x it changes. So I will divide and multiply with delta x over here. So shall I write here? Okay. So this is delta x. I will suppose multiply over here delta x divided by delta u as it is, plus already sign, and instead of that here y changes, so delta y, and divided by your delta y upon delta u. Now I will take a limit. Okay, limit delta u tends to 0. This is limit delta x tends to 0, and this case will be simple. Okay, so this is nothing but limit delta u tends to 0, delta f divided by delta u, which is nothing but limit delta x tends to 0, this term f of x plus delta x, y plus your delta y, minus f of x comma y plus delta y divided by your delta x, okay, into this limit delta u tends to 0, this is delta x upon your delta u, plus I will write this term limit, what will be change, delta y tends to 0, this is definition of your x, y, okay, and y plus delta y minus your f of x, y divided by delta of your y into limit delta u tends to 0, delta y upon delta u. Now please remember here the partial, this is nothing but partial differentiation with respect to the x where y is constant. Okay, now this x is a function of u, means single variable is there, so we can write as delta u tends to 0, delta x become your dx and delta u become your delta means du. Okay, because this is depend on single variable, here is the partial function is there. So as you know the definition, this is f is again function of single variable u, so this is df divided by your du, which is equal to delta f, now x it changes, okay, here dx by du, don't confuse here, delta u become when you are taken limit and delta u tends to 0 means this is du, delta x become your dx and delta y become your dy. Okay, so because this is depend on single variable, plus daba f by daba y, this is a function changes, y changes, x is your constant, into dy by du. Just we have seen this particular in terms of t. So this is your formula for when any function, what we have taken initially, f is a function of your x and y, and again this independent variable is function of suppose something u, and y is also function of u, then we can write this is df by du is nothing but daba f by daba x into dx by du. Okay, daba f by daba x means the continuous partial differentiation of a given function with respect to your x, means that's why we have used the partial, continuous partial, and this is differentiation with respect to u, means dx by du plus daba f by daba y dy times means dy upon du. Now suppose this is f is a function of your x and y, and x is again function of u and v suppose, and y is a function of u and v, means two variable or more than two variable. So what is the in general formula in this case? Okay, so in this case, so for single variable, this we have written the x is a function of u only. Now x is a function of two variable or more than two variables, so we have to generalize one formula. So we can write the f is a function of more than two or more than two variables. So I can write this is daba f by daba u, here df by du, because f is a function of u only. Now here f is a function of u and v. So daba f by daba u, which is nothing but daba f by daba x into daba x by daba u plus daba f by daba y daba y by daba u. Many students they will write phi over here. This is not case. This second you want to find out daba f by daba v. So this is daba f by daba v, which is nothing but daba f by daba x into daba x by daba v plus daba f by daba y and daba y by daba v. So suppose this is u, v, z something, so just you have to add the terms over here, same thing, and you will get the additional term, suppose daba f by daba w. Okay, and you will get. So this is about your chain rule. So this is very simple thing. So you have given any function, means this is just like it is a function of x, y and z, something variable is there, and these independent variables is again function of some another variable, just like u, v, w, just like this one, and y is again u, v, w. Again suppose you have taken third variable z, and that is again u, v, w. So in that case you have to follow this particular continuous partial differentiation, and this is also your partial differentiation of x. Here is the differentiation with respect to u. Here u is depend more than one variable, so 2 and 3 this. So in that case you have to follow this particular case. Okay, so we'll take one example so you will understand what I am to say here. Okay, so some student might be have questions. Suppose we can use earlier we have taken two problems, so just put the values and you will get. This is okay. Okay, but any complicated problem is there, that time you have to follow. Okay, any simple problem is there, then that case you can just put the values and you will get the answer. But when any complicated function is there, that time you have to use such a formulas and you will get the answer. Okay, so problem suppose, so this is one case problem. Suppose z is a function of x e raised to minus y, okay, and x is cos hyperbolic t and y is cos t. Okay, so here the z is a function of whom? X and y, and x is a function of whom? T. Okay, so we can use direct our formula. So what is our formula? And your aim is what? Delta z by delta t. So this is delta z by delta t, which is nothing but dz by dt. Sorry, this is z depend upon. So delta z by delta x into dx by dt plus delta z by delta y into dy by dt. So this is delta z by delta x is what? This. So this delta x by delta x is 1, and you will get e raised to minus y into dx by dt. Dx by dt means this is our cos hyperbolic t. So that become sin hyperbolic t. How this is possible? So we know in complex number, suppose this is d by dt of x is what? Cos hyperbolic t. How we can write cos hyperbolic t? E raised to t plus e raised to minus t upon your 2, and you want to take d by dt. Okay, so if you take on this is half is outside, so e raised to t, so that is e raised to t, and again the differentiation with respect to e raised to minus t, so this is minus e raised to minus t. So this is what? This is nothing but sin hyperbolic t. Okay, that's why we have written directly dx by dt. So x is cos hyperbolic t, means hyperbolic cosine of t, which is nothing but hyperbolic sine of t, plus, okay, delta z by delta y, okay, with respect. So x is constant, so what is the derivative? This is minus e raised to minus y. So I can write, instead of plus, this is minus x e raised to minus y dy by dt. Dy by dt cos derivative is sin t. Okay, so I will take e raised to suppose y common. So we have to put the values because this is function of t. So all the variables. So y is equal to your cos t. So this is your cos t. So I will take outside suppose. So what is inside? Sin hyperbolic t minus x is what? Cos hyperbolic t. This we already taken outside, and this sin of t. Okay. So such type of problems you have to solve this particular case. Okay. Second example is suppose you have given f is a function of suppose x and y. This is multiplication of, this is composite function. Okay, and x is equal to your r cos theta and y is equal to your r sin theta. Okay, so which formula we have to use here? Now see, this is x is a function of whom? R and theta. Here x is function, y is a function of r and theta. Here f is function of x and y. So simple, we have to use delta f by delta r. First I will find out. This is delta f by delta x and into delta x by delta r plus delta f by delta y into delta y by delta r. Same case you can find out for theta case. Same, instead of r you can put theta value and you can solve such a problem. Another one complicated problem is there, so that we'll see, and then we'll see the physical significance of this particular term. Okay, problem is very simple. So this is f is equal to, suppose, under root of u square plus v square, and u is a function of, this is cos ln of ln tan p plus 1 by 4 pi, and v is a function of sine ln tan of p plus 1 by 4 times pi. And now your aim is what? df by dp. Okay, so see, this is f is a function of whom? U and v. This is u is a function of whom? P. Only they have taken, this is ln, tan, and then it is depend upon the function, its function. So it is depend upon several things. So this is very simple. You can go just straightforward way. So deba f by deba p, which is nothing but means df by dp, which is equal to deba f by deba what? U into du by dp. Okay, plus deba f by deba v dv by dp. Deba f by deba u is nothing but what? This one. So we know this is symmetric function. So this is u square plus your v square raised to half. And when you have taken du of such a function, so it is just like what? Half times u square plus your v square raised to half minus 1 into derivative d by du, which is nothing but your u square. So this is become what? This is half will be here. Okay, this is your u square plus your v square raised to minus half, and derivative of this u square with respect to the u is twice u. 2 get cancelled. I will take this down. So u upon u square plus your v square, and that is your under root. Yes. So same thing we can write, instead of deba f by deba u. So this is u divided by under root of u square plus v square deba u by deba p. Okay. So cos derivative is what? Minus sine. Okay, minus sine time ln of tan. Okay, we'll write this ln tan p plus 1 by 4 times pi. Okay, again inside derivative, this is sine derivative, cos derivative is minus sine. Now derivative of this particular term with respect to your p, so that is nothing but what? D by this is p with respect to that down term. So that I can write what? This is 1 upon tan p plus 1 by 4 times pi. Again derivative of your tan. This is cos derivative is minus sine. Now inside derivative is what? Ln of any function is nothing but 1 by that particular function. So 1 upon tan this particular function we have taken. Now again derivative of that function. So tan of, so this is nothing but sec square. This is p plus 1 by 4 times pi. Now see, this is complicated things. Okay. plus here you will get the same thing, dA by f by dA by v. DA by f by dA by v is nothing but this with respect to the v. So instead of u, you can write v under root of u square plus your v square. Okay, so this dA by v by dA by p. Sine derivative is cos ln of tan p plus 1 by 4 times pi, okay, into this is derivative of ln term. This is 1 divided by your tan of your p plus 1 by 4 times pi, okay, into the derivative of this one is sec square p plus 1 by 4 times pi. Okay, now again put the values of u and v over here. Okay, so this is cos square something theta, sin square, this will be 1. U value you can point out in terms of p. Okay, so instead of u, you can put this particular value over here. This is goes to 1, this is also goes to 1. Okay, sec square tan theta will be coming outside, so I'll write that particular term, suppose. So this become u is what? U is your cos ln of tan p plus 1 by 4 times pi. This is become 1 because cos square and sin square theta will be your 1. Now from here I will take what? Sec square. Okay, so this is remaining over here. So inside the bracket this will be, so this I will again common, sec square inside this, or we can write one more step anyway. This is sine of ln, this is minus this is p plus 1 by 4 times pi divided by, means this is your sec square p plus 1 by 4 times pi divided by tan of p plus 1 by 4 times pi, same term plus v. Okay, so here under root of that term is there. This is cos square into whole this bracket plus sin square into whole this particular bracket plus v times v is what? This is sine of ln tan p plus 1 by 4 times pi, okay, divided by under root of, this is again cos square this bracket plus sin square this particular bracket, and inside this is cos ln of tan p plus 1 by 4 times pi. Okay, so this is just mathematical step, not big task, only you have to go step by step and you will get answer. This is your tan of p plus 1 by 4 times pi. Now which thing is common over here? So this is your 1, this is also 1. Okay, so I can take sec square p plus this will be common, this is also present here. So instead of that, what we can write, I can take, this is sec square p plus 1 by 4 times pi divided by tan of p plus 1 by 4 times pi. Okay, this is again, suppose we will write in terms of sine and cos, and one term is goes. Okay, so this is equal to, what is inside? cos. So this is minus term. Multiply this term inside. So this is minus cos into this whole bracket into sine into this whole bracket, minus sign we have taken here, plus already we have taken, this is outside, this is your sine, this is your cos. Okay, so this is sine into this particular same bracket is there, and cos times sine. So this get cancelled and you will get 0. Okay, so what value you will get 0 over here? So this is f df by your dp. Suppose z we have taken that particular function, so df by dp you will get 0 over here. So f is constant function, probably you have get. So depend means the function, the in general is what? Suppose this is f is a function of something different variable g of x, and you want to find out df by your x. So you have to do that particular formula now, this thing over here. So this is about your chain rule. Now we'll see what is the physical significance of chain rule, why we are doing one function and that depend upon another, and you want to find out what is the final motto. So that we'll see using one example. So here I will take one hyperboloid problem.